video, we are going to be looking at functions, right? So we first of all have to understand what a function is. It's a mathematical research that for every input there's an output, often y, that results. So let's take for example this function now. We have y equal to 3x plus 5, right? So for an input, let's say 3. 3 into 3 plus 5, that's 9 plus 5, that's going to give us 14. We have an output right there. You get it? So another thing to note here is that the function is a set of ordered pairs, right? It describes a set of ordered pairs where x and y are non-empty sets, right? X and y are non-empty sets, so that means they contain elements in them. So the first important symbol we need to take note of is R, which represents the set of all real numbers, showing the integers, the rational numbers, the irrational numbers, the natural numbers, right? Integers consist of positive and negative, rational numbers, irrational, natural numbers, or the counting numbers. We can see that their values range from negative infinity to positive infinity, right? Then the next symbol we're going to look at is Z. Z represents the set of integers. That's, for example, from negative infinity, that we are now having 9 minus 3 minus 2 minus 1 0 down, right? So set of both positive and negative integers. Do we get it? So if we then want to specify whether it is positive or negative, it will be represented by Z plus, right? But if it is negative, it will be represented by Z minus, right? Negative integers, positive integers, they just integers. They're going to have negative 3, negative 2, negative 1, 0 downwards, forward, right? So another symbol to take note of is n. We have n, and then that's n. It represents a set of natural numbers, or we call them counting numbers, right? So if we just have n, it's a set of counting numbers 1, 2, 3, 4, 5, 6. But if there's n and there's a bar on top, we are talking about negative counting numbers, negative natural numbers, minus 1, minus 2, minus 3. The only difference here is that z will include both negative to include 0 and to include positive integers. Then for the third one, q represents the set of rational numbers, a set of rational numbers, and then we have in bracket a comma f of a. What does that mean? We have a, and then f of a represents the function of a. What are the outputs that we can get, right? For a, b, which is a member of z, and the function is defined by a over b, where b is not equal to 0. The number is defined by a over b, where b is not equal to 0, because at b equal to 0, it is not defined, it is not a number, right? So this is kind of like a building block for us to determine the range, the domain of rational functions. So another thing to take note of is that the union of rational and irrational numbers is going to give you the set of what? All real numbers, because the q, which represents rational numbers, is made up of integers. Integers are rational numbers. For example, 5 can be written as 5 over 1. It's still a rational number, right? Integers are rational numbers, and then including the other ones like 5 over 7, 3 over 8, so on and so forth, which are real. Then union q prime. You know what prime means? It complements, right? So the union of the rational and the irrational numbers will give you the set of all real numbers that exist. Then now let's move to what are the conditions, right, for a function of a number to be said to be what? Rational. So in general, function or a number is rational if and only if, number one, the denominator is not 0. In the case of a function, if the denominator is 0, the function does not exist at that point. For example, if we have f of x equal to 1 plus x over x minus 7, the function does not exist. If we have x minus 7 equal to 0, you take the negative 7 on the left to the right hand side and it becomes positive 7. So at s equal to 7, the denominator will be 0, and at that point the function is not defined. And then if you have a number, the denominator too cannot be equal to what? 0. The second point there is that it should be a terminating fraction, right? It should be a terminating fraction. In the case of 3 over 5, right? In the case of 3 over 5, we have 3 over 4, sorry, we have 0.75, right? So it's going to terminate at some point. But even though it's not terminating, that's the third point, if it's not terminating, it should what? Reoccur. You can see a sequence that reoccurs. So for example, 5 over 7, right? So what is 5 over 7 in your calculator? 5 over 7 is 0.714285. 714285, it continues in that sequence, right? So you can see that is a reoccurrence. In the case of 1 over 3, we have 0.333, there is a reoccurrence and is what? Non-terminating. That tells you that that number is what? Rational. So hence we can see that all rational numbers are fractions, but not all fractions are rational. In the case of pi over 2, pi in the first place is what? Not rational. If you check the value of pi, in your calculator is equal to 3.1415, 926, 653, 589, 793, 23. Right, you can see that it is non-terminating and what is reoccurring, and there is no reoccurrence, right? Because you can see 1415, there is no sequence that repeats itself here, right? E, which is Euler's number, is not also a rational, it's irrational. E is equal to 2.718281282845904523. So you can see that there is no reoccurrence in the mantissa, that's the fractional part of this stuff. Now let's look at the important terms to note, right? So the domain, right? You need to know what the domain is. You need to know what the codomain is all about and what the range is all about. So the domain is simply the set of possible inputs a function can take and to still exist, right? And is denoted by dom f, right? While codomain is a set of possible outputs, right, in a function. So let's take an instance of academic excellence, right? We're talking about academic excellence. What are the efforts you're going to put in? What are the inputs you have to put in to achieve that? So the set of possible inputs that the function can take can still exist. In the case of maybe you are not studying or you're not doing assignment, you're not studious, what happens? For that function, for that value of not being studious or not being serious with your assignments, the function of academic excellence is undefined. So in the case of codomain, the set of all possible outputs, totality, every possible output that function can give, right? While range could be equal to the codomain, or it will be a subset. It may not contain all the elements in the codomain, but it must be a subset of the what? Codomain. And then you should take note of what we call the source set and the target sets. When we are talking about source sets, we are talking about the set that contains the domain. So that is where we are deriving the function. Those are the values for which the function exists. Then the target set contains the codomain, or you can say the range. That's what the target set is, a set of values for which was stated, right? So let's consider the representation f of x, f as x maps to y. So what does this represent? That means x is a non-empty set, y is also a non-empty set. And what do we have here? X represents the set of possible inputs, right? That x contains a set of possible inputs that it can take, that function can take, which is the first entry, while y contains the corresponding output, which is the second entry. Now let's look at the real valued functions. So if set A is non-empty and A is a subset or equal to, when you see that symbol, it means subset or equal to the set of real numbers, then what happens? The function of A to a set of real numbers is said to be real valued. The function of A to a set of real numbers is said to be real valued. And then you should note what sum, product, and quotient is talking about. You know the symbols that I used to ask. You want to find the sum of some functions. How is it represented? It's represented by S. Right? If it's product, by T of x. If it's quotient, R of x. You get it? Quotient have to do, maybe if you have two functions, f of x, and then we are dividing by what? G of x. That's what quotient is all about. And this connects to rational functions, right? And another thing I need to tell you about rational functions is that if a function is rational, what happens to it? The numerator and the denominator must be what? Polynomials, starting from degree 0 upwards. You get it? So example, in the case where we have f of x equal to 1 plus x over 7 minus x, what happens in that case? The numerator is a degree 1 polynomial because the highest power of x is 1. The same applies to the numerator there. Then there are some symbols that we need to understand. The first one is inverted A, and it represents for all or for every. When you see something like that, you're talking about for all or for every. And the second is you see something like an E that is curved. This is what it means, is a member of. Then the third one I've already explained from the beginning part of this video, right? And it means what? Is a subset or equal to. Is a subset or equal to. Then the fourth, when you have an equal sign and then a slash in between, what does it mean? Not equal to. I hope you get it. So understand this symbol so that when they write it out, you'll not be confused as to what they are talking about. Then let's look at the real value functions. Once you just understand each of them, you'll be able to get the it. That no matter how the question is twisted, you will get it. So let's look at the first one, constant function. Constant function. So now what is constant function? From the name, you should be able to understand it. When they are talking of constant function, it implies a form where we have f of x equal to k. Are we getting it? Where k is a constant. So what happens here? What happens here? K can be 1, k can be any number, right? So consider the xy coordinates. This is x, this is y, right? And then we have a straight horizontal line. This line represents the line f of x equal to k. It can be on the negative side, it's not only on positive side. It can be x of x equal to minus k. Do you get it? So what are we trying to say here? We are trying to say that for all possible inputs that the function can take, the output will be what? K. That means for every point, for every first entry, the output is what? K. I hope we are getting it. For every first entry, output is k. So if we trace it now, this value will take k. This value, all values, positive infinity, negative infinity, are going to take k as they are depending on what the value of k is. Right? So very simple. Another thing that they have said about this constant function is that the range is a what? Singleton set. So we can therefore say that the domain of a constant function is what? All real numbers. Because whether positive or negative, the output will be what? K. Then what is the range? Remember, range is a set of possible outputs. Possible output, and we have only one possible output, which is the what? K. That is why in the material we have already said that the range of a constant function is a singleton set. That means contains only one element, which in this case is k, depending on what k is. Then the second one we move over to is signum function. So what is signum function? Take it from the word sign. Do you get it? Take it from the word sign. Very, very easy. And what are the three possible signs a number can have? Is either that number is positive, or is negative, or what happens, or is zero. Those are the three possible things. Either is positive. So for a signal function, note that is applied in electrical systems, engineering systems, and all of that, input on and out, stuff like that. So what are the three possible values? What are the values that a signal function can take? Right, let's look at that. -1, 0, 1. Y. Let's look at this xy coordinates. This is y, this is x. So the signal function is represented by this: y is equal to 1, y equal to -1, and right here we have the origin 0, 0. Are we grabbing? So what happens here is that for all possible positive integers, that's in this region, as you are going forward to positive infinity, the output of the signal will be what? 1. That means if you are positive, the output will be 1. If you are negative, the output will be what? -1. While if you are 0, you remain at 0. So what is the domain of a signal function? All real numbers. Because if you call a positive number, we'll have an answer, which is 1. If you call any negative number, we'll have an output, which is what? -1. And then if we call 0, it will be 0. So there are only three possible outputs, which is -1, 0, and 1. So the range is a set containing what? Minus 1, 0, and 1. I hope that's understood. Now let's move to heaviside. We are talking of heaviside, right? When we are talking of heaviside, we are talking of similar to signum, right? In heaviside, we just have a straight line here, right? We have a straight line, y equal to 1 here, right? Y equal to 1. So what happens here? If the number is positive, it will take 1, just like in signum. But if it is negative or equal to 0, the output will be 0. Unlike signum, that if it is negative, it will take minus 1. So hence, in general, we can say that for a heaviside function, if x is less than or equal to 0, the output is what? 0, right? But if x is greater than 0, right, that's from 0 to positive infinity, what happens is what? 1. That's what it is in general. So I hope we get it. That's what the heaviside function is talking about. Now let's move to the absolute value function. Absolute value function. Very simple. Understand the concept clearly and you get it. So for absolute value function, what happens in absolute value function is in the form x. We have two vertical lines by the side of the function that is involved there. So what information do we need to know about this function? The important thing to know here is that whatever is the inputs, whatever you are inputting into that function, the output must be a positive number. It must be positive. We get it? So it must be positive in nature, right? It must be a positive number. You get it? So if, for example, absolute of minus 19 is going to give us what? 19. To transpose it to the positive, if it is positive, it will remain positive. Do you get it? Then absolute value of minus 200. Absolute value of minus 200, what is it going to give us? It's going to give us 200. Absolute value of 200 will give us 200. So if we consider a function, absolute value of x, right? Let's say here is 1, 2, 3. Minus 1, minus 2, minus 3. The absolute value of 1 will be what? 1. Absolute value of 2 will be 2. Absolute value of 3 will be what? 3. Absolute value of minus 1 will be what? To still be 1. Absolute value of minus 2 will be what? 2. Absolute value of minus 3. Absolute value of 0 is what? 0. So you can see that it's kind of like V-shaped in nature. Do you understand? So the line or the graph does not go to the negative, that's negative y-axis. All the outputs are always positive. Hence, we can say that the domain of an absolute value function, we can have all real numbers, right? But if we're now talking about the range, it is from what? 0 to what? Infinity. Is the set of real numbers from 0 to what? Infinity. Because we cannot have negative outputs. But if what we're having is negative, the absolute value function will transpose it to positive. That's what it's talking about. Then let's move to greatest integer value function. Let's be fast about it. So greatest integer value function is represented with these two square brackets and then whatever function it is. You can have something like this. This is what I'm drawing. So you see it clearly. I have something like this. You can have something like this, 2x plus 1. It can be any function in between. So what's the key factor about this? Right? Because in the exam, they could say f is equal to greatest integer value function of 2x plus 1. And then they now say find f2. If you substitute so what will you get? So the point here is that if they're asking for greatest integer value function, the first point is that what is inside the bracket is an integer, whether positive or negative, what happens to it? It remains the same. For example, greatest integer value function of minus 3 is what? Minus 3, right? It is the greatest integer value function is simply the greatest integer that is less than or equal to that number. Let's say call it x. So in this case, minus 3, it will be equal to that what? 3. But if it's now less than, if it's now maybe minus 3 point, if it's fractional, sorry, If you have minus 3.5, you look at the number line. Look at the number line. We have 0, 1, minus 1, minus 2, minus 3. Before minus 3, you have minus 4. Minus 4 is less than minus 3. So minus 4 is the greatest integer that is less than or equal to what? Minus 3.5. And that is what? Minus 4. So they could give you something, and then in this case of absolute greatest integer value function of 2x plus 1, and then they'll say where x is 1.6. Right? If you take where x is 1.6, 2 times 1.6 is what? 3.2. 3.2 plus 1 is 4.2. So what is the greatest integer value function of 4.2? It is 4. Because that's the greatest that is less than or equal to what? That number, which is 4.2. The greatest integer. Right? So I hope we get it. So then if we are now talking about the domain, it can be all real numbers because anything can accept. It's just the output that is going to change, which that's the range. Right? Depending on what it is. Depending on what it is. For example, if it's the case of 0 to 1, between 0 and 1, what happens? Between 0 and 1. If you have between 0 and 1, any number between 0 and 1, the output will be what? 0. That means from negative infinity to what? To 0. That's what we're having. We have that inclusive there. That is based on the function it is. So this, when you are evaluating domains on this, is based on the function. We'll do all this in part 2 of this video. Just understand the main concept. When you are inputting values, if it is an integer, you leave it like that. If it's greatest integer value of 15, it is 15. But if it's now 15 points, or is a fraction, you convert it to decimal, and then you then get the one that is less than or equal to it. You get it? Then affine, very simple. And here of affine is a linear. It's actually, I won't actually say linear, but it's in the form y equal to ax plus b, where a and b are constant. So if you consider the xy coordinates, here is y, here is x. So we can have different lines. You plotted lines in secondary school, right? Both junior secondary school, senior secondary school. So all those lines, most of we don't pass through the origin, represent affine functions. And the domain of an affine function is what? All real numbers, right? All real numbers is a polynomial of degree 1. The highest power of x in an affine function is 1. Do you get it? So all real numbers can enter and there will be no issues because there is no limitation. Right? All real numbers can enter. No wahala. Then we are not talking of the range. You can still talk of the same thing, depending on what the function is. So all these polynomials, depending on what the function is all about, right? Then we can talk about the range. Then if you are looking at polynomials are of the form a0x0, a1x1, a1, that's x raised by 1, plus a2 x raised by 2, plus a3 x. You can see the power is increasing, depends on which polynomial it is. So for polynomial functions in general, their domain is what? Positive, right? Their domain is what? All real numbers, because they can accept any value and they will still exist. You get it? Then for example, let me give a question so that if you see something like that, you can be able to get it easy. Right? So if you see anything like that, you won't struggle at all. So this can be asked in exam, where you have y equal to, they can give you 4x raised to the power 5 plus 9x raised to the power 4 plus 6x squared plus 7x plus 16, and they ask what's the range. No stress, this is a polynomial, right? The powers are increasing, decreasing. You have the powers there. This is a polynomial of degree 5. So what's the answer? All real numbers. All real numbers can accept any value. There is no denominator limiting it, right? There is no square root that you say square root of a number cannot be negative, right? Not in the middle. So you can accept it. Then the range of a polynomial function is gotten by calculation, because we will now have to study the graph of the function to know the set of values that it can accept. And that range is determined by the what? A0 and the an. That means, and also depends on the power and all of that. For example, if it's quadratic, you have to take up some processes to like b squared minus 4ac less than or equal to 0 to determine all these things. Do you get it? So the most important thing to note here is that domain of polynomial functions is what? All real numbers. Then for root functions, what is root function? Root function is in the form nx. So what is the determinant of the domain and the range in this case? The point here is that if n, sorry, this is n. If n is odd, for example, we are asked for the cube root of 27. What is it? To give you 3, because 3 times 3 times 3 is what? 27. If you are asked for maybe cube root of 1, what is it? Is 1, because 1 times 1 times 1 is what? 1. Cube root of 64 is what? 4. So what do we notice here? If you ask for cube root of minus 64, can you see that it still exists to be minus 4? Why? Because minus 4 times minus 4 is what? 16, right? Because minus times minus is plus. Then that 16 times another minus 4 is what? Minus 64. So we can notice that if the power is odd, that's n is odd, what happens? You can accept any real number inside that root. It can be positive, it can be negative, it can be 0. But when it comes to an even function, let's use square root as an example, because for square root the n value is 2. Do you get it? The square root of 4 is plus or minus 2, right? But when it comes to determining the square root, of minus 4, we have problem. It's a complex number, not real numbers, and we're talking about real valued functions here. So for negative integers, root functions that have n even don't exist. Do you understand? So if you're asked maybe nth root of 64, you can be asked this exam. What is the range of, what's the domain of this function? It's simply what? From 0 to what? Infinity. Because negative values it will not accept. It can accept 0 and above. That's what we're trying to say. So for roots that are even, can accept values inside the root function 0 and above. But if it is odd, negative or positive can enter and there will be no issue. That is why they ask you what's the domain of, let's say, x minus 2 third root. What will be the answer? It will not be, you will not go and equate x minus 2 equal to 0 and say x minus 2 crosses over, right? And it now becomes x. No. You now say all except 2. No. Because the power is, the nth root is 3. Whether positive or negative, it will accept it. Right? So the answer to this, the domain of this is actually all real numbers. So we've understood the main gist here. Thank you so much for watching this video to this point, and I encourage you, please like this video. Number 1, share this video to your fellow mates that need it, that want to understand the introduction better, right? And then also, most importantly, click the subscribe button. There's no fee attached to clicking the subscribe. Just click on the subscribe button to get other free videos that will come from this tutorial, math study tutorials. So quick info is that part 2 of this topic is coming up soon, right? So that one is not going to be a free video, it's going to be paid. By the time it's out, you will get information about the price. It's going to be a very cheap price that is affordable, and then I hope you're able to grab all that I taught in this video. So do well to also comment, ask your questions in the comment section, and then I will be happy to answer you. Thanks for watching and have a great day. Right? Yeah.